In this video, we'll discuss procedural abstraction. So in the previous video, we talked about symbolic abstraction, which was the idea that we take a simple name and use it in place of complex values. With procedural abstraction, it's a similar idea. We're using a simple name now, though, to refer to complex processes. So it's sometimes referred to as black box abstraction because the user of a process doesn't need to know how the process works. So the process itself is a bit of a black box in that regard. The user just needs to know the name, the number of inputs, and the expected output. Once they have that, they can use the process without knowing the line-by-line details. So essentially with procedural abstraction, we're giving ourselves a nice simple handle for a potentially complex process. Now there's two concepts that are intertwined in procedural abstraction. On the one hand, we're creating a procedure, and on the second part, we're giving it a name. Okay, so the procedure object is an entity unto itself. Naming it is effectively incidental. But for now, we're going to do these two things as one step. Okay, they are separate concepts, but we'll be doing them together for now. We'll distinguish as the course moves forward. So if we want to create a procedure in Scheme, the syntax is as you can see in the slide here. Define, as we did with variable, the keyword define, some name and a list of parameters, and then in this triangle here, the body. Now the triangle brackets here are just to represent placeholders. You don't actually use the triangle brackets. The round brackets are in fact mandatory. So let's walk through an example here. If we want to, for example, define the squaring function, we could say something like define the square of x is times xx. So to square something, we multiply it by itself. Okay. Now, as I mentioned, the syntax here starts with the keyword define. Then we have some name. In this case, our name is square because we're creating the square function. We have 0 or more formal parameters here. These are just symbols, placeholders for actual values. And then we have the expressions that make up the body of our function. Now, if we want to execute this function, we can run our code here and type in square and then provide some value for the parameters. So for our argument, we'll say 3. 3 goes into x. We get times 3 is 9. Now notice we didn't have to say return in order to make this work. The body of our function just evaluates down to a value, and that is the value of the function call or the function application. Okay, so an expression where we say square of 3, the result of that is whatever happens when whatever value whatever value is the result of executing the body of that function with that argument, in this case 3. Okay, so we can use square in a few other ways. We can, for example, say square of plus 3, 4. So we can take the result of some combination and pass that into the function. It can also be the result of some other function or even the same function. So I can say the square of 3. And that becomes square 3 is 9. 9 goes into the outer square here. We get 9 squared is 81. Okay. Worth pointing out as well, if I just say what's the value of square, we get procedure square, which is to say when we say define here, we're creating a binding between the symbol square and this procedure object. So similar to when I say define x to be 3, we're creating a binding between the name x and the value 3. Here when I say define square of all this, we're creating a binding between the name square and the value, which is the procedure object square here. Okay, so the procedure itself is the value. Now, there's different uses of this define keyword. As we've seen, we've used it to use it to create variables as well as to create procedures now. So I just want to quickly show you the key difference here. If we want to create a variable, say define a to be times 5, for example. Okay, so we have keyword define, some symbol, and then this thing here is going to evaluate down to 25, and we'll create a binding between those two values. So we'll say, what's the value of a? And it has the value 25. Now, if I want to create a procedure, I'd say something like define b to be times 5. Now, this is a bit of an odd procedure because it doesn't have any parameters here. It has the name b and then no parameters, but the brackets are still mandatory. And notice the brackets are the only difference. On line 3 here, we don't use brackets, we get a variable. On line 4, we do use brackets, and we get a procedure. And the difference can be seen when we run it. So if I say, what's the value of a? We get 25. I say, what's the value of b? It's a procedure. And if I want to run that procedure, I wrap it in brackets saying execute this function on its 0 arguments, and our answer is 25. Okay. Notice if I tried the same thing with a, we get an error. We've seen this error before. The value of a is an integer. We're trying to apply an integer as though it were a function. That doesn't work. Okay, so the same keyword define will either create variables or procedures, depending on whether or not we're using the brackets here. Now, as a bit of a mnemonic, if you want to try and remember the different syntaxes, or if you're looking at a define and you're trying to figure out is this creating a variable or a function, the key difference here is the first part of this define statement, right? We're saying define and then within brackets, and this highlighted bit here, square and then the parameters, this looks an awful lot like how we would call that function, right? We say square of 3. So the function call looks an awful lot like the name and the list of formal parameters in the define statement. So if our define statement looks like that, if it looks like there's a function call in it, well, then we're creating a function. If it doesn't look like there's a function call in it, then we're creating a variable. Hopefully that gives you some help in terms of remembering the difference between the two. It's also worth mentioning at the outset here of the course, the terms procedure and function, they do technically have different meanings. Procedure is more of a computer science term relating to a step-by-step sequence of instructions, whereas function typically refers to the mathematical sense, or even in computer science is a procedure that returns a value. The course textbook uses the terms interchangeably. I prefer function, but Dr. Rackett uses the term procedure, so you'll see me use it interchangeably as well. So procedure and function for the purpose of this course, there's no need to distinguish between the two names, or between the two terms. Okay, so let's do a slightly more involved example here, just to see how all of our abstractions can help us build complex entities. So we're going to build a procedure out of calls to other procedures. So for example, I can say define sum of squares of two values, x and y. And I'm going to do that using the square function that we just created. So the sum of squares is the sum of the square of x plus the square of y. Okay. Now when your functions get big, typically you won't create them on a single line. So usually the first line is just define and then the header or the signature of your function. And then what follows is eventually a well-organized body here. Block of code using the same breakdown technique we saw in previous lectures, where we have the operator and then vertically align its operands. Okay, so here's sum of squares. It's a function. It takes in two values and adds the result of squaring each of those values. So it calls the square function in order to do its work. So let's run this code and type in sum of squares 3, 4. Okay, and our answer 25. So 3 goes into x, 4 goes into y. We get 3 squared plus 4 squared is 9 and 16. We add those together and we get 25. All right, so the whole point of this is that the functions that we're creating, so square itself abstracts the notion of squaring, to in this case say multiplying two values together, but that abstraction then becomes a building block in larger levels of complexity, for example summing of squares. And perhaps somebody wants to sum of squares in some larger application, we can define a function on top of that, right? I could say something simple like nonsense function here, but define f of a to be the sum of squares of a plus 1 and a times 2, something like that. Now we have a function f that takes in a single value, but its result is dependent on sum of squares, so we give sum of squares two values, and its result is dependent on squares, so we give square one value each, and eventually it'll calculate that, and we'll have this whole computation tree go through. So make sure you understand that, how it calculates a value here. So if I said f of 3, see if you can figure out what the answer is before running that code. Now, one other thing I want to mention about functions for this video is the notion of sequencing. Now, in imperative languages, sequencing is generally speaking assumed, right? Imperative languages have the general structure of do this, then do this, then do this. But functional programming is intended to be declarative. That is to say, we shouldn't be focused on the order of operations, the doing this, then the doing this, then the doing this. Functional programming focuses on substitution and reduction of expressions. Okay? So scheme's a little bit imperative, so it does have some sequencing in it. But generally speaking, sequencing isn't a functional programming notion. That's more scheme's imperative side showing through. So sequencing means we can have a sequence of instructions executed one after the other after the other. And in a functional language, this is generally speaking only useful for side effects. So if I said something like define, call it pretty sum AB. So this is going to do a simple addition, takes in two values A and B, adds them together, but it's also going to do some displaying so that the user sees the entire computation. So it'll say display A, display the plus symbol, and display B. Then on a new line, display the equals symbol. And then finally, we'll just return the value A plus B. And since they're in the same console, the display will happen in the same place as the result. Okay, so let's run this and see what happens. Run our code, and if we say pretty sum, say 2 and 3. 2 plus 3 equals 5. Wonderful. So the whole point of this is that the body of this function has, 5 or 6 expressions here. Display, 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 new line, display, and then some addition. Okay, so it does all of that work. It walks through one after the other, which is to say the body of a procedure has some implicit sequencing. Okay, so it does one, then the other, then the other. But the value of a procedure, so if I ask what's the value of pretty sum, so I can say define result to be the value that comes out of this, sum 2, 3. The value of that is the last expression in a procedure. So in this case, the last expression in pretty sum is this addition. That's the thing that gets returned, so to speak. It's the value of this combination. Okay, so the last expression in a sequence is the result. Okay. Now, the only purpose to having sequencing is to allow side effects, which is pretty much only useful in terms of displaying things for now. Since we don't have mutable values, we can't have side effects in that regard, so we don't have to worry about those. So there's sequencing for you. And again, all procedures, they do one after the other, but the value of a procedure, the result of a procedure, is the value of the last expression in that procedure. So one last example here. If I say define my function A to be plus A1, say times A2 minus AA, and then A. If I were to run my func on 17, what is the value of this expression? So pause the video, see if you can't figure that out before you actually execute it. Welcome back, and let's see the value here. Run, and my func 17 has the value 17. The reason being, all of these things, they happen, so we get 17 plus 1 is 18, 17 times 2 is whatever that is, 34, and 17 minus 17 is 0, but then the value of the expression is just 17. It's just the last line there, right? If we didn't include this, if we got rid of that last line there, then the new last line here is minus AA, and if we run our code again, we can see the result is the value of that last expression. So whatever the last expression is in the function, that's the value of the function when it executes. All right, that's it for this video. In the next video, we'll go on talking more about some of the more nitty-gritty details of the basics of Scheme. I'll see you there.